Hello everyone and welcome to this webinar on practical examples of multi-call verification and live network issues. My name is Patricia and I'm going to be your host for today's event. So before we move on with the presentation, I have some information to share with you. First of all, you'll be able to submit questions at any time by using the Ask a Question button. Just note that the question will be answered at the end by the presenter. At any time during the presentation, you can share it using the Share This button. This session will contain poll questions, so you'll be able to answer and view the result by using the Vote button. After the presentation, you will be able to access the slides of this presentation in PDF file using the Attachment button. You'll also be able to access the on-demand presentation of this webinar immediately following its conclusion using the same login information you used to register today. At the end of the presentation, you'll be redirected to the survey, and upon completion of this survey, you'll be entered into a draw for a chance to win a 500 Visa gift card. As for the volume and the screen size, the control buttons are located at the lower right hand of the webinar player. So today's webinar will be presented by Tommy Tallgren, who's Senior Product Line Manager at Exfo. Tommy has more than 10 years of experience in the telecommunications industry, with expertise ranging from support engineering to technical sales to product management for the Exfo Analyzer product line. Last year, his focus shifted to live LTE network analysis and troubleshooting, working closely with leading LTE MNOs around the world. So have a good presentation, everyone.
Thank you, Patricia. So this webinar will be actually a third one in a series of focusing on voice over LTE. So if you want to hear actually more detail and more specifics about voice over LTE and the signaling of it, so please check out the exfo.com and the webinars out there. Today we're going to focus on voice over LTE in the network side, so the focus on the network part of the LTE and a few topics. So we check out the VoLTE call verification, a couple of examples of the VoLTE issue detections, what you need to detect, and then a few slides on the root cause analysis. This webinar is more practical due to the fact that we are just using the slides, so I'm going to use a lot of screenshots, and all these analytics and the screenshots are from the real live LTE networks from a different TED calls we have done around the world. And all these screenshots are actually coming from our TravelHawk Pro, PowerHawk Pro, Exfo passive analysis product line. And please, once more time, ask questions anytime. This is a webinar, but you could think about this as a presentation directly done to you. So ask your questions and I'm answering them in the end, and I'm also checking them in the meanwhile. So I might answer some questions directly also during the slideshow as well. One specific thing before we go forward, before I start, so I'm gonna put a poll on the screen. So before we go to VoLTE call verification slides, so I'm gonna give a vote for your own plans and timing, what you're supposed to be seeing right now. So when are you planning to introduce or test or optimize the VoLTE in your LTE network? So please select the best possible answer depending on your situation right now. You can go ahead, and I'm gonna stop the voting in maybe 10 seconds or so right now, and we can actually see the results just to understand what is the current audience status in the voice over LTE and part in their LTE networks. Since I can see still votes coming in, so I wait a few more seconds. You're supposed to select the best possible answer. and we can actually see the results. Practically currently underway, so it's a very hot topic indeed, because altogether almost 60% is saying that it's ongoing right now or in the coming 6 months. So very much in the good topic then to discuss with this audience right now. You can close the voting button and I will go forward for the slides. So VoLTE call verification itself. So which are the main topic actually to take the VoLTE voice over LTE call and verify the new services? I put it in the 3 slots here. First of all, what seems to be really the most difficult one is that you actually have an actionable data in your hands. It's not easy to verify the voice over LTE call if you just have a handset. Well, you can verify that it went through and the voice quality was good, but if there's any issues, you actually need an actionable data from your LTE network and end-to-end view in that sense. And so practically test calls in the network or utilizing the subscriber calls and possibly capture end-to-end data as we had there in the earlier webinars. We walked through all the interfaces needed for the really verifying completely the voice over LTE call. Then really the focus on the analytics side. So the steps for analyzing the call, what we actually focusing with a couple of examples in this presentation. First of all, you need to find the calls. The faster, the better, and you need to find the call based on the IMSIs or phone numbers, for example. Check the KPIs practically to check out if there's something urgent right there in the KPIs section. And then you verify the LTE signaling part. I point out a couple of points in the voice over LTE, what kind of things you need to verify. Then you go for the SIP RTP session side to really verify the service of the voice over LTE. And then naturally the quality of service is a one specific topic. What is the KPI to really define if the VoLTE call was successful and in a good quality enough. And then the third part, the reporting itself. So when we do the verification, it's very important that we actually have the facts and details available for later analytics. So these number 2 and number 3, we are going to actually touch base in this presentation. So first of all, find the users and check the KPIs. Voice over LTE calls, you practically have 2 different ways to connect the information. You can focus only the voice part itself, practically the SIP and RTP data. So that will be giving you the part of the story, and you would be capturing this information, for example, from S1U interface directly in the eNodeB side, or from S5 interfaces in the packet data network, or directly to the IMS network interfaces. That means that only having the SIP and RTP data in your hands, finding the user is practically available only by the phone number. As in this example, there is an example from our subscriber analytics search window, which we can see an example of call ending 7876, and it practically will select all the calls ending by this specific number. Another possibility to really to see end-to-end voice over LTE and verify the full functionality of the VoLTE is that you actually have end-to-end data, meaning that also LTE signaling data from S1U, S11, S6A, that you can actually verify also the peer information. In these cases, you would practically use the IMSI as qualifying thing to search the call or the user. IMSI search will give you the full end-to-end view from your network as well as from the user plane. And additionally to that, it also gives you the view of what the user has done in addition to the possible voice over LTE call, what might affect to his voice over LTE service as well. So ideally, IMSI is an ideal way to search and really see end-to-end activity by the user. Now the KPIs then in the second hand. So First things what you would check out that if there's anything specific happening there in the signaling side, if the attach was fine, if the bearer creation was fine, just to see that if the customer actually even get a service. Once this is done, we will later go a bit more deeper. You will go for the SIP KPIs. Practically to see that what if he has how many sessions he was trying to do, what was the completion rate, the session success rate, if there was any specific errors, or what was the most value in the average point of view from the specific user. So these are the things what you are looking for the KPI side. So call verification or service verification, find the user, check the KPIs. If things are fine, as we can see in this example, this is from the subscriber analytics, we can see that there actually was some issues in the calls in this specific example. But if the KPIs are practically okay, you would go to the next step, and that is a session level verification. In the session level verification, there's practically two specific points to define. First of all, LTE end-to-end control plane session, and then the SIP session itself, the SIP signaling session. And there, the checklist practically would look the signaling first, check out the attach and the registrations to the LTE network as well as to the IMS. The bearer creations, they were correctly done and fine and without errors. Then you're looking also the SIP errors or SIP by reasons, just to see that if there was any issues in the SIP side. In the configuration side, practically if your APN or the PDN gateway is not correctly defined by the user or by the user's service availability, so practically you will be having a problem right in the beginning to register to the IMS network. Not to say that there won't be naturally a connection to your IMS network by the dedicated bearer later on when the service itself is established. So these are the first thing to check out, especially when verifying the new services. Now, in the SIP RTP session side, as I said, you're practically looking, of course, that if the call went through or not, and if not, so what was the SIP reasons, maybe the error reason or SIP by reason, if there was one, and then the quality of the call itself. We will go a little bit more deeper on that one. But now just pointing out the checklist to define when verifying the voice over LTE calls. Now, then one specific topic out of really detecting the signaling and on the both side, from the LTE side as well as the IMS and SIP side, is to have a specific focus on the quality of service parameters. In voice over LTE, there is practically two things what need to be defined correctly in your network to ensure the quality of the voice over LTE call. First, the bearer quality class indicator itself in the control plane side. Practically, we are looking for QCI1 for conversational voice defined by the 3GPP, and then maybe a 5 or a higher quality bearer also for the IMS signaling side for registration, for example. So this is the first thing to check out. These are just the shortcuts from the specific voice over LTE call with a specific column, all focusing on the same call. But this quality indicator doesn't really do anything if this is not mapped to the real bearer quality in the packet network itself. So, and in the packet network itself, the bearer quality number one, as we can see here, little cuts of the voice over LTE call, we can see that how that translates to transmission level in Ethernet and the IP level priority points. So Ethernet priority code points, we have the highest priority, the 5 for the voice itself, and we can see the second highest priority 4 utilized for the SIP signaling. And the same way in the IP, this is the IPv version 6, so we have the traffic classes and the similar quality parameter in IPv4 type of service is indicating that you actually have a correctly defined network for your services. So this is only telling that the bearer what you are defining for your voice over LTE voice is not only in a correct priority inside the network elements in the E node B, but also in the data network side as well, and it's translating to the transmission quality of service correctly. And then naturally the quality of the voice itself. So MOS score is the most commonly used quality parameter. In our system, we calculate the most passively from every single RTP flow, and here is just a session level overview of the MOS score. AMR wideband code used here, and very good quality indicators also seen. So VoLTE call verification, the analytics part itself, practically will reflect then directly to the reporting. So once you're reporting the voice over LTE call, practically the KPIs are telling you the amount of calls done, how the network is behaving, what is the percentage of failures, and so on. And then you go for the session level verification, where you report the session data from both LTE side as well as the SIP side, and then naturally the specific key performance indicators for the voice over LTE call. And if these are all matching to your requirements, so then you practically has a correct verification for your call itself. Then and the issue detection itself. VoLTE issue detections are practically following very much the same path as what we have for the verifications. Now, naturally, you are looking possibly already known issues, or you are looking issues what you don't even know exist there for the voice over LTE call. So, a couple of practical examples from the issue detection. So, what you are looking for, very same thing. So, we are looking at the KPIs practically to find out where we should focus first. So, if you have a network level statistics are showing bad values, so that's the place where we want to hit first to find an issue and fix the most problematic case. And then you go for details. So in the LTE session analytics, you look for the attach error itself. So practically, if you don't get your voice call through, so first thing what you look from L2N analytics, that did my connection to the network as well as to the IMS network were correctly done, and if my configuration was correctly done. And then you look if the network is behaving correctly based on the QCIs. And then after the session bearer is correctly figured out, so you will go directly to the voice over LTE services, looking at the SIP signaling side. Errors during the call, just to find out if there's issues in the IMS or devices or the service itself. And the last part then practically looking the issues in the data streams itself, in a transmission level as well as a quality of service level. The KPIs. So two level of KPIs shown here. So practically network level KPIs and then the user level KPIs or session level KPIs. So in our analytics, we define those separately due to the fact that when we are looking for network, we are practically looking at possibilities to select certain time frame and then define the query based on the transmission level information like IP, practically for focusing on specific E node B or BDN gateway, VLAN to focus specific areas, or even a TTP user plane IP, so focus on specific IMS servers or even to the specific user. And that in the high level view, we practically are seeing, if you look the example here, so we can see SIP sessions. This here we have no filter on, so it's only time selection. We can see there's over 100,000 SIP sessions in uplink and downlink. Some 32,000 errors there also in the SIP, so clearly there was some serious issue there. We can see the procedure failure rate. So practically a couple of specific KPI indicators in top of how much data there has been into the network. What is the average flows in RTP and SIP? What is the average MOS? So practically the network level average for the voice quality itself. Network level KPIs are practically meant for that. So I mean, you find out the issues, any bigger issues. If there's alarming case, you will drill down and you will use the filtering mechanism to drill down for a specific element, or to find out that you have a specific issue in the service along your network. And then the user group, where we actually define a specific user or a specific set of users, as the filtering enables you to, for example, look all the specific IMSI types or specific phone number sets at the same time, just to see more detailed the SIP Volter related information. So we are looking for the session success rates, also the establishment effectiveness, then of course the call duration itself, the setup times, and any issues in the voice or video failures, as well as once again the most scores. So issue detection starts from the high level naturally, to find out if you have any kind of specific case in your hands where you can pinpoint to the root cause. Then one practical example of an issue found in the voice over LTE calls. So once you have an issue, what you might know or might not know, there's two ways to find out issues. I mean, you could just look all of the errors you have and see that if they're happening more than what you are expecting in your network based on your data volumes, or you are looking already at specific issues. Here we have the RTP timeout happening in the voice call. So practically, RTP timeout, you don't really see that in the signaling side, nor it is a SIP specific error. I mean, the SIP call is just nicely ended by the buy. But then if you look the SIP buy reason, you will find out the issue there. So two ways to find out. I mean, practically select the user and then select the SIP code to find out the specific call by this specific user, or go directly to the network level data and just select the specific by reason code and see all of the issues with the RTP timeout, for example. In this example, we select the test mobile, select the RTP timeout to find out the specific SIP call, and then we will go deeper to actually find the root cause. So in the timeout issues, first of all, you are defining, you find the call, you can see the call, you can see the voice quality is pretty okay. Then you will go for the next step to really find out and verify the issue itself. So verifying the timeout issue, you would go, there's multiple ways to verify it. In this example, I've selected this throughput analytics, just selecting the RTP flows. This is once again a cut from the bigger screen, but where you can see those MOS scores average and the maximum minimum in the system itself. So you can actually see that these are the RTP streams. So I select uplink and downlink RTP stream and just give me the throughput analytics of these streams over time. And in the small screen, you can see the results, how the call in the end is actually stopping completely from one end, and there's no data coming into the one direction at all. In this case, this is pinpointing to the correct element, that being the eNote B. So we can find out, yes, the session service itself is working correctly. It is giving us a correct indication. There was actually RTP timeout, and it's happening from the eNote B side. Now, to go further after the verification is a troubleshooting. And troubleshooting, you practically would select another option we have here in this option list, drill down to protocol monitor. That would give a possibility to go deeper in the protocol monitor and actually find out that in this case all the signaling and all the data is stopped. Not only the RTP stream, but also the SIP buy doesn't get a response. So we can further find out the root cause and go deeper that this is actually a completely a connection problem by the user itself. Having the control plane information in top of that, we could correlate and see that if there was an issue in the bearer itself, or was it just the issue with the eNote B not sending further of specific bearer data. So these are all the deeper possible outcomes when we go deeper to find the root cause of the call, and we support all of those. Then in the root cause analysis, a couple of slides before I go for the answers. So in root cause analysis, practically we are doing pointing out this common factor for any kind of an issue. If this is one user having a specific issue, so we just find the user and we report the specific case, and we drill down to the protocol level if needed to find out that who was really the reason for this specific error. But then it might be also that it's a network level. So network element level, you're practically looking KPIs per different network elements just to find out that if the element is actually behaving worse than other, and you can focus on fixing the specific network element. Service level issues, practically looking the whole network behaving wrongly, and practically it's a network independent but the service specific issue. For example, if you have no registration working, so you are maybe looking at a certain element in the IMS network that you are not going to get any kind of registrations, even if the current calls might go through just nicely. Transmission network issues, so practically if you do the quality parameters, so the first thing to check out is that what is the reason for this low quality, and the mobile side, the IMS network side, or actually the transmission network issues, what is causing the delays or jitter for the packet transfer, and that's causing the low quality of the voice. We also have naturally, you can also listen to the voice, so if the MOS score is not giving you detailed enough information, you can also listen to the voice that, for example, if end of the call there was an issue, so you can hear that issue in the voice quality itself. Then the user device, practically pointing out for the IMSI or the phone number, pointing out that the specific users are only having the issues, and pointing out towards the network, user equipment, telling that it's not a network issue, but it's actually there in the device side. Process, practically it's a process for the experts to initially to focus the correct point in the first, or a try and error. So practically eliminating and finding the root cause itself, drill down for the example to find to verify that that's actually the root cause to be fixed, and then exporting the analytics and all the graphs and exporting the raw data so that the second level support or yourself are able to fix the changes, maybe configuration issue, or report to the vendor of the services or the equipment to fix it. And once we do the reporting part, so practically important that you are including the analyzed results there, the flow information, the subscriber overall view, graphs, whatever graphs you have been doing, you export that to your report as well as the raw data. Very important that you export the message flow and pick up the file itself from the example. And that's where the analytics and the ease of use come to the picture, that how fast you are able to get to this point. If you handle LTE network, let's say you have a few gigabytes of data there and you are looking the issue, end-to-end issue from the LTE network. If you take a half an hour of data from a few gigabits of complete LTE end-to-end network data, so you end up easily to 1 terabyte of the raw data. So that's not the raw data you want to start exporting and importing and sending forward. That's going to take you tens of hours just to get the data out and get it back to the third level support. But instead of utilizing the analytics on the box, and in our case, 1 terabyte takes roughly 40 to 50 minutes to analyze, if it's comparable for maybe 20 million LTE sessions and some 100 million of LTE user plane sessions. And out of that, it's only then a matter of seconds to find the user or specific error, because all the analyzed data is in the specific database where we can really find all the details in a matter of seconds. Now, once you have the error in your hands, you can export the file, and then you only have a few kilobytes, or if you have a user plane included, maybe a megabyte of file, what you can just email to go forward. And that's where the huge savings of time in a practicality comes into the picture. The details itself, we practically, you can go all the way to the message flow and message detail level, so that's up to the need of specific use cases. So you might be okay for the graphs or KPIs, so the certain network is not working correctly, or a specific problem in a specific example sessions, you might need to go all the way to the message detail level. Before I go for the conclusion and questions, I will put another vote for you, and this is about if you would be actually interested in live demo of the solution what I presented. So to see it over WebEx for yourself, just to see that how it actually is working step by step, click by click, or actually see your own network, so we can come over and do a voice over LTE audit for the live network, and this is also possible. So please select if you are interested about that. I'm not going to show these results in public, but just for us to know that if you would like to give us to give you a presentation, more detailed, maybe more animated with the real data instead of just the slides. So let us know. I can see that I have lots of questions coming up, so I will then go forward later on and after this one and go on answering for these questions. Okay, thanks for voting those. I'm going to stop this voting and I go for the conclusion, just a couple of slides, and then I will go directly for answering your questions, so you can keep on putting them in as well. So just one slide, all of these done analytics, what we are doing. So Exvo has in a passive side for the voice over LTE, we have two specific product line. PowerHawk Pro, what is a distributed probe system for 24/7 real-time network cluster or network analytics. And then we have a TravelHawk Pro, what is also for the live network, but it is more of a need-based. Both systems supporting over 30 gigabits per second stream to this. So even portable device, you can practically put this device to any of your packet core network. It has 4 times 10 gigabit links if you really need lots of data. Line rate hardware filtering naturally, but also in case you need all the data in, we can capture over 30 gigabits per second to this specific box. Full voltage coverage, so we have the LTE PC analytics, we have all the voice over LTE SIP analytics KPIs for the network. So end-to-end view and the correlation for one user over all of the interfaces as well as including the user plane is supported. And then the performance to really do the analytics for the live network in a very short time. So performance is really matching for tier 1 LTE networks. So this is our offering. And then before you go after the questions, so please complete our survey. You are automatically directed to the survey, and we are giving $500 Visa gift cards. We have been giving them out already during the last year, I think quarterly based. So you have a very good chance to win practically a cash prize by putting your information and answering for our survey. And then I go for the questions. So practically, I go just one by one. I have lots of questions here. You're asking here, what tool are you using in the slide 8 to analyze the voice over LTE call? Practically, all of these examples are analyzed. Mostly of these examples are actually analyzed by our TravelHawk Pro, but the analytics itself are similar for our rack line system, what is 24/7, and the portable system, which is more you capture a certain data amount and then you go and analyze the information. This is more for step-by-step post-processing needs. Do you have all KPIs supported like SER, SEER, MO, NER? We have a part of the KPIs requested are supported. So our fact sheet, we actually define what information is supported, session establishment rate, and stuff like that. Not everything. So especially in voice over LTE, we are constantly bringing up new KPIs. And especially in the coming releases, focusing more in the network level KPIs as well, not only a session level. So please contact for the details for us. Then we have a question, is it possible to perform the same analysis for other services like the video file transfer, IM, and etc.? Yes. So our analytics is Voice over LTE is just a one service, but we actually utilize a DPI engine inside our system, and we are automatically detecting practically any applications out there in the internet. So you can define same way with different video services. You can actually define if it's a YouTube or if it's a Silverlight or whatever application it is, and so on. And each of the application they has a specific kind of details and what is available for a specific application. So it is possible as well as other than just for the Voice over LTE. Then in the root cause analysis, I have a question: can we filter number of abnormal SIP-by causes by abnormal UA context release messages? Practically, currently the system is so that every information is in the database. So practically, all of the information what you are able to detect by us, and we have both of those supported, can be used as a filter. However, if you would do the SIP-by, you can practically combine that also to the LTE session, like here UE context release message itself. You are practically you need to do a couple of queries to find them at the same time. So, but I'm going to put that actually a mental note by myself and see that if we can do that in the one slot to actually check out that if the radio issue was the reason for the SIP-by specific errors. But I can see a use case clearly here. Then we are asking a 3GPP or GSMA standards KPIs for the Voice over LTE. Yes, I mean they have to define the quality, of course, for the Voice over LTE, defining the bearer quality, defining the jitter and delays and all that. So this is available by 3GPP. Then we have also our own KPIs which we are giving out. So if you are asking specific KPI, how do we calculate that KPI? If there is a specific factory standard, so we will tell you exactly what we use to calculate specific KPI. Then we are requesting to use that analysis from UU, X2 or S1 node onwards. And practically in our current passive network analytics is focusing on X2 and S1, so practically from E node B forward. So the radio data, we have another tool set which is also can analyze the radio data, and this tool set we are actually having analysis probe into the itself, the user equipment itself. So if you just put the question and we will answer for that as well into the end of the after the presentation, we will give you the information about the radio interface analytics as well. Can you do a poll QA analysis? Actually, we're doing the type E passive voice quality analysis from our side, and for the so we are not doing the poll QA right now. And then we have there's a question if there is a separate model tool to take MOS from field. So practically, as I said, so we have the MOS analytics. What we are doing is from the network side, and we are doing automatically for every single call. The MOS for the radio part, so we have another tool set in Expo which are able to do that. So I will forward the question for information for you for this question as well. Then there's specific questions for need-based analysis for Travelhawk and the differences for the 24/7. So practically, we have a set of practical use cases for Travelhawk Pro. There's two big use groups. Operations teams in the operations, practically utilizing Travelhawk Pro for all of those holes they might have for the monitoring system. So, for example, if you have a case where you need to drill down to the eNode B, you most likely don't have the probes in every eNode B. So in need-based, you can move this around very easily, go to the eNode B and analyze issues directly from the eNode B side. For example, the transport issues which are relevant for where you are actually getting the data from. And then there is cases with all the national or high-level Tier 3 support teams. So as I said, getting the actionable data is many times the biggest headache what there is. And for that, the portable tool will give you the full independence of getting the data. So if you need to go to the network which you might not have a full access to the monitor data, having a portable tool will give you the full access to this one as well. We have questions actually coming in, and some of the questions I will not be able to answer during the time limit, so I will answer all of them also after this one. So you can still put the questions in. I will answer directly to you. What are the export options of traces? So practically, we use the open standard PCAP for exporting the trace files. So you are able to export the traces pretty freely. You can define a specific filter for yourself that, okay, I want to export all the traces coming from this IP address, or you can select a specific call or user, export all the data, PCAP file, control plane and user plane automatically correlated for a specific user, or you can just do it with selecting specific dedicated issue cases, or you can just export all of the data if you want from the system and analyze it with another system. One more question about the MOS calculation. So we use this ETT type E passive MOS calculation. So we're not using any PESQ or similar methods for the voice quality because we're using passively analyzing the data from each interface and then analyzing it based on that type E method. What else we still have? Questions I could answer just before we close up. And then there's one question, maybe this is the last question. Can I use this tool offline as well as with exported traces? So yes, you can actually use this tool directly from line, or you can import any traces, any PCAP traces, even the folders full of traces. We automatically merge them based on the timestamps, and we analyze this data. So it's also a powerful tool for analyzing the data from any sources if the data is in the PCAP format. It's also possible. So I thank you now. There's a lot of questions there, so I'm going to answer all of those questions after the webinar. Thank you very much. Please check out the rate and ask the survey, so you are able to get to this $500 USD gift card draft, as well as rate these webinars, and check out the attachments where you can see also the materials what was presented today. Thank you very much.